Hi, my name is Joe Nagy, and I did my Google Science fair on stabilizing Einstein-Rosen bridges, which are most commonly known as wormholes. Now, when I first began my Google Science fair project, I wasn't really sure what I wanted to do specifically, but I did know that next year at college I wanted to perform research in the physics department. So, to find inspiration on my project, I went on my university's website and looked into what their physics department is currently researching. Now, after a while, I found some research papers written by a professor named Arlie Peters, and saw that he was researching properties of black holes, which I thought was very interesting, and I might want to engage in similar research next year. So, I began looking through general press articles on black holes, and after a while I found a new theory that was discovered that related wormholes to black holes, and that's how I was inspired to start my project.
The application of this project would be to decrease the amount of distance needed to travel to get to another area of spacetime. So, for example, if scientists on Earth wanted to observe the star Vega more closely, normally they would have to travel 25 light years to get there, but through stabilizing an Einstein-Rosen bridge, they would be able to take this shortcut through hyperspace to observe the star. I wrote an original Java program that uses two main methods to stabilize a wormhole. The first is called the Casimir effect, which is a phenomenon in quantum field theory that uses differences in the energy density outside of the wormhole and inside of the wormhole to pull it together, thus stabilizing it. In my Java program seen here, the amount of force generated from the Casimir effect is calculated. The second method is through exotic mass, specifically negative mass, which is mass that will have the opposite gravitational force of normal mass. This is used on both ends of the wormhole to push the two mouths together to achieve stabilization. In the original Java program, the user is prompted to enter different values of the wormhole environment. After all of this is entered, seen here, the program then calculates the amount of energy density in the system, and then finally the amount of force generated by the energy density, seen here. Then, the program sets that force equal to the universal gravitation formula, which then solves for the amount of mass needed to counteract the force generated by the energy density. Ultimately, further research in stabilizing Einstein-Rosen bridges would lead to a much improved method of traveling through the universe by decreasing the amount of distance needed to be traveled, and would also lead to major scientific advancements in learning about the universe.